You know that latest GPT release? It might seem like just another software update on the surface, but if you look closer, it actually tells a story that connects the entire AI industry. I mean, from the economics of the software all the way down to the physical power grid. So let's unpack it.
Okay, here's the plan. We're going to start with what seems like a small software tweak, and then we're going to zoom out layer by layer. We'll look at the models, then the chips that run them, and finally, the actual electricity that powers the whole shebang.
So this latest model update from OpenAI, it really wasn't what a lot of people were expecting. It wasn't some massive leap in raw intelligence that made all the headlines. It was something a lot more strategic.
Whenever a new model drops, the first question everybody asks is it smarter? Is this a huge step towards AGI? But here's the thing. This time, that's actually the wrong question to ask. This update wasn't just about making the model think better. It was about making it think cheaper. The whole release really was designed around cost and efficiency. By hugely increasing the number of tokens, which are basically just pieces of words that they can process, OpenAI sent a huge signal. The name of the game isn't just about raw performance anymore. It's about making this whole operation work economically at a massive, massive scale.
So how do they pull this off? Well, it all comes down to this core concept called the AI router. Honestly, the best way to think about it is like a really smart traffic cop for your questions. It sits there in front of all of OpenAI's different models and decides which one is the right and, most importantly, the most cost-effective tool for the job you're asking it to do.
And this router, it's not just some clever technical trick. No, it's actually the key to unlocking a massive, completely untapped market. The hundreds of millions of people using the service for free.
It's a pretty simple but totally brilliant triage system for compute power. So you ask a question, and the router instantly tries to figure out its potential value. Is this a simple question, just looking for information, or is it a question that might actually lead to a purchase? Based on that split-second decision, it sends your query down the right path.
This quote just nails the business logic behind it. Why on earth would you waste your most expensive, most powerful models on simple questions? It makes no sense. But if a user's query shows they might be about to spend money, like finding a lawyer or booking a hotel, you go all in. You dedicate your maximum compute power to give them the absolute best answer possible.
And this is the endgame. This is how OpenAI can finally make money from its enormous free user base, not by plastering it with ads, but by becoming a kind of agent that helps you get things done and then takes a small cut. It's about capturing a piece of the economic value that their models are already creating out in the world.
But why is managing compute costs so critical in the first place? I mean, why go to all this trouble with these routers? Well, it's because one single company has a near-total iron-fisted lock on the hardware that powers this entire revolution. We're in a full-blown AI gold rush. And so far, the most consistent winners aren't the AI labs finding the gold. Not by a long shot. It's NVIDIA, the company that's selling the essential picks and shovels to every single miner out there. They provide the fundamental hardware that everyone else has to build on top of. NVIDIA's dominance isn't just about having one faster chip, it's a fortress. For example, better networking means their chips can talk to each other way faster than anyone else's, which is absolutely critical for these giant AI jobs. And superior supply chain leverage? That means they get better prices on everything, from the silicon wafers to the cables connecting them, making it almost impossible for a competitor to even match their costs. So, if NVIDIA is the undisputed king, can anyone even build a viable alternative? The challenge is, well, it's absolutely immense. And it really boils down to a single brutal number.
5 times. A challenger can't just be a little bit better, they can't even be twice as good. To have any real shot at competing, your hardware has to be a staggering 5 times better at a specific job.
So why 5x? Why is the bar so incredibly high? Well, even if you manage to design a chip that's 5 times more efficient in a lab, by the time you factor in all of NVIDIA's other advantages, their supply chain, their manufacturing speed, even their ability to just cut their own prices to fight you off, that 5x advantage might shrink down to maybe a 50% improvement in the real world. And that's often just not enough to get a big customer to switch. The main challengers really fall into two different camps. On one side, you have the giants, the hyperscalers like Google and Amazon. Their big advantage is that they are their own biggest customer, so they can absorb costs and design chips for their exact needs. On the other side, you have the startups, who are nimble and can bet on a totally new kind of architecture. But both of them face huge hurdles. The big guys struggle with internal politics, and the startups have absolutely zero leverage against NVIDIA's massive supply chain machine.
Okay, let's do our final zoom out, because everyone, OpenAI, Google, the startups, even the king, NVIDIA, is starting to run up against the exact same ultimate bottleneck. And it's not a digital one, it's a physical one. When you look at the cost of a modern AI data center, you see something kind of surprising. The huge majority of the cost, like 80%, is just the upfront capital expense of buying all those chips and networking gear. The ongoing costs, like power and cooling, are actually a pretty small slice of the pie.
And what that means is that time is literally money. When you've spent billions of dollars on chips, every single day that they sit in a box, not running, is a massive financial loss. Speed is the #1 priority. Getting a data center online just a few months faster is worth way more than saving a few bucks on the electricity bill. And this brings us to the final and maybe the biggest barrier of them all. The real bottleneck isn't the price of power, it's the availability of it. It's the sheer difficulty and time it takes to build new power grid connections and substations. The result? Companies literally have billions of dollars in state-of-the-art GPUs just sitting idle, waiting for their data centers to get plugged into the grid. It's gotten so crazy that tech giants are now buying up old crypto mining companies, not for the Bitcoin, but just to get their hands on their existing power contracts. So we've gone from a single software update all the way down to the absolute limits of our electrical grid. What you should take away from all this is that this incredible technological race is being fundamentally constrained by real-world physics. The future of AI isn't just about bits and algorithms, it's just as much about atoms, power plants, and concrete.